So we looked at the shift cipher, and now we want to look at another kind of cipher where characters are replaced with other characters called an affine cipher. So an affine cipher. So the encryption function for an affine cipher will take on the following form. The code is going to be congruent to A times M plus B mod 26. In this case, we're doing mod 26, since we're only going to be converting the 26 uppercase letters of the alphabet. So A and B will be positive integers. And also we want the GCD of A and 26 to be 1. In other words, A and 26 should be relatively prime. Now we'll talk about why that's the case later. First of all, C is a variable, and that's the code. M is a variable, and that's the message. A and B are going to be fixed positive integers, and we'll call the encryption key A comma B. So the A and the B are your encryption key. So we want to encrypt the message using an affine cipher. So exercise. Encrypt the message using an affine cipher with encryption key 5, 3. And the message here is sail for Bermuda. So what I'm going to do, I'm going to convert the message to numbers. This is the message in numbers. So 0 through 25. So S is 18, A is 0, I is 8, L is 11, F is 5, O is 14, R is 17, B is 1, E is 4, R is 17, what is M? M is 12, U is 20. Is that right? U is 20? Yeah. Okay. D is 3. And A is 0. So if our encryption key is 5, 3, that means A is 5, B is 3. So our encryption function is going to be C equals 5M plus 3 mod 26. So here I want my code and numbers. So I want to convert 18 to a new number using my encryption function. So I'm going to do that down here, maybe my scratch word. So I'm going to take 5 times 18 plus 3, mod 26. Let's see. 5 times 18 90, so we got 93. Maybe I'll do it up here. 93 mod 26. Take 93 divided by 26. We get a quotient of 3. So 93 minus 3 times 26 gives us the remainder is 15. So C here is 15 mod 26. So first we get 15. Now 0 is amazing. So I'm going to have 5 times 0 plus 3 mod 26. That's going to give me just 3. Let's see now, next I'm going to do 8 times 5 plus 3 mod 26. That's going to give me what? 43 mod 26. Second, just take 43 and subtract 26, and I get 17 mod 26. 17 is 8. Let's do 11. 8 times 11 plus 3 mod 26. That's what? 88 plus 3 is 91. Divide 91 by 26. I get a quotient of 3. 91 minus 3 times 26. I get a remainder of 13. Let's convert to 13 mod 26. So 11 is 13. Now let's do C is congruent to 8 times 5 plus 3 mod 26. Oh, 5 times 5. What am I doing? I got my encryption function all screwed up. Let's go back. It's 5m plus 3. It's not 8m plus 3. I had 8m plus 3. It's 5m. Okay, let's do this over again. Okay, so 0 goes to 3. That's correct. So now we're taking 5 times 8 plus 3 mod 26, which is 43. And 43 minus 26 is 17. Okay, I did that one correct. 17. Okay, we did that one correct. Let's do 11 again. So we do 5 times 11 plus 3 is 58. What's 58 mod 26? 58 divided by 26, quotient of 2. 58 minus 2 times 26 gives a remainder of 6. So 11 should have been 6. Now let's do 5. 5 times 5 plus 3 is 28. 28, well, you can mod that by 26, so you get 2 mod 26. So 5 goes to 2. 14. 5 times 14 plus 3 mod 26. 5 times 14 is 70 plus 3, 73. 73 divided by 26. 73, we got a quotient of 2, so minus 2 times 26 is 21 is the remainder there. They got a 21 in place of 14. Now 17. 5 times 17 plus 3 mod 26. So it's 5 times 17. It's 85 plus 3. 88. 88 divided by 26 gives a quotient of 3. 88 minus 3 times 26 gives a 10 remainder. So we got 10 in place of 17. Now 1, so what we're doing, 5 times 1 plus 3, that's just going to be 8. Simply 8. let's do 4. 5 times 4 plus 3 is 23. Mod 26. 17, we already done is 10. 12, I'm gonna have to do some erasing here. I forgot what we're doing, 12. This damn thing's not working. There it goes. 5 times 12 plus 3. Mod 26. Well, that's 63. So 63 divided by 26 gives a quotient of 2. So take 63 minus 2 times 26 to get the remainder of 11. Okay, so 12 gets replaced with 11. Now let's do 20. 5 times 20 plus 3, mod 26. It's going to be 103. 103 divided by 26, quotient of 3, so we're going to take 103 minus 3 times 26, and a remainder of 25. 20 gets replaced with 25. Let's see. 3 should be easy. Let's see. 5 times 3 plus 3. It's 15, 18. 18 mod 26. And 0 is my favorite. It's, let's see. 5 times 0 plus 3. Mod 26 is just 3. All right, so let's put the code here into letters. So 15 is P, 3 is D, 17 R, What is 6 here? 6 is G. 2 is C. 21 is V. 10 is K. 8 is I. 23 is X. 10 is K. 11 is L. 25 is Z, and 18 is S, and 3 is D. Yeah, there's our code. Just another exercise. Suppose an affine cipher has an encryption key 5, 4. One, find the decryption function. And after you do that, decrypt the following: OY, HYJ, LEVY, QB, LSRI, JLY, AC. All right, so we want to find the decryption function. So we know A here is 5 and B here is 4. So our encryption function is going to be, the code is 5 times the message plus 4 mod 26. So we're going to subtract 4 from both sides, and we'll get that 5 times the message is congruent to C minus 4 mod 26. We're going to multiply both sides by 5 inverse. And essentially on the left side, the 5 inverse, and the 5 are going to cancel, you get the message equals 5 inverse times C minus 4 mod 26. So what we got to figure out is, what is 5 inverse? What is 5 inverse? So how do I find the inverse of 5 mod 26? I want to find 5 inverse modulo 26. But to do that, I'm going to use a Euclidean algorithm. I'm going to take my modulus 26, divide 5 into it. I'm going to add a quotient of 5, a remainder of 1. I'm going to take 5 and divide 1 into it. I'm going to get a quotient of 5, a remainder of 0. So now I'm going to take my last positive remainder. That's my GCD 1. I'm going to get it by itself. I'm going to say that 26 minus 5 times 5 equals 1. Now, keep in mind that when we're trying to find 5's inverse, we're looking at 5 times something, we'll call it, what should we call it? D? 5 times D is congruent to 1 mod 26. So D here is going to be the inverse of 5. So what I'm going to do, I am going to rewrite this as, well, if I can rewrite this, 5 times negative 5, and I'll subtract 26 from both sides now, so I'll have 26 times negative 1 plus 1. And that statement right there that you see is the same thing as 5 times negative 5 congruent to 1 mod 26. So our inverse here is that green negative 5, but we don't like negative 5 as our inverse. So our D is negative 5 mod 26. That's our inverse, but we don't like negative numbers. We want our number to be from like 1 to 26, so we'll just add 26. So D is going to be here. The inverse is going to be, what happens when you add 26 to negative 5 would be 21. That's what 5 inverse is. So it's going to be 21. So I'm going to have M is congruent to 21 times C minus 4, not 26. So that is a perfectly good decryption function right here. Now, some people would actually see they don't like negative 4. They don't like negative numbers, so they'd actually add 26 to negative 4, and they get 22, and then they distribute 21 through and reduce that all mod 26. But it's fine. They'll leave negatives. Now, the idea is that we actually want to decrypt here. We want to decrypt this. So if I want to decrypt this message, I want to convert my O here to 14. So this is the code and numbers that we're going to write. So O is what, 14? Y is 24. H is 7. Y we said is 24. J? What's J? 9. L's 11. E is 4. V is 21. Y we said is 24. Q is 16. B is 1. L is 11. S is 18. R is 17. I is 8. J is 9. L is 11. Y is 24. E is 4. And C is 2. So we want to decrypt, so we want the original message in numbers. So I'm going to subtract 4 and add, multiply by 21. So I'm finding my message here. 21 times, let's see, 14 minus 4 is 10. So I get 210. Divide that by 26. Get a quotient of 8. So 210 minus 8 times 26 gives me 2. So 14 goes to 2. Now let's do 24. 24 minus 4 is 20. So what's 21 times 20 is 420. Ooh, 420. Divide by 26, get a quotient of 16. 420 minus 16 times 26 is 4. 24 is 4. I see another 24, that's 4. And another 24, that's 4. And another 24, that's 4. All right, 7. 21 times, let's see, 7 minus 4 is 3. We're going to multiply that by 26, so we got 21 times 3 is 63 divided by 26. Quotient of 2, 63 minus 2 times 26 is 11. So I got 11 for 7. Okay, let's do 9. 21 times, let's see, 9 minus 4 is 5. What's 21 times 5? Well, it's 105. We're going to multiply that by 26. Let's divide by 26. Quotient of 4, so 105 minus 4 times 26 gives us a remainder of 1. All right, so 9 goes to 1. 9 goes to 1. How about 11? 21 times, let's see, 11 minus 4 is 7, mod 26. 21, well, calculator's not working. 21 times 7 is 147, divide that by 26, get a quotient of 5, 147 minus 5 times 26, 17. 11 is 17. 11 is 17. 11 is 17. All right, let's do 4. That's the easiest, right? 21 times 4 minus 4 is 0. Not 26. 0. Happy about 0. So 4 goes to 0. Any other 4s? Yeah. Let's do 21. 21 times what? 21 minus 4 is 17. Come on, 26. 21 times 17 is 357 divided by 26 is, there's a quotient of 13, so we take 357 minus 13 times 26, get a remainder of 19. So 19 is, 21 gets sent to 19. Are there any other 21s? I don't see any others. Okay, let's do 16. 21 times 16 minus 4, 16 minus 4 is 12. Let's do 21 times 12. 21 times 12 is 252 divided by 26. Gives a quotient of 9, so we're going to take 252 minus 9 times 26, and we get a remainder of 18. So 18, 16 goes to 18. Any other 16s? Don't see any. Right, so let's do 1. 21 times 1 minus 4 is negative 3. Well, negative 3, we can add 26 to that. Negative 3 plus 26 is 23. So 21 times 23, mod 26. Let's multiply 21 times 23. 483, let's divide by 26. Get a quotient of 18. 483 minus 18 times 26 gives me a remainder of 15. 15 replaces 1. Any other ones? Don't see any. Okay, next is an 18. I'll work over here some. 21 times 18 minus 4 is 14. Mod 26. Okay, what's that? 21 times 14 is 294 divided by 26 gives a quotient of 11. 294 minus 11 times 26 is 8. So 18 gets replaced with 8. How about 17? 17 minus 4 is 13. 21 times 13, 273. 273 divided by 26 gives a quotient of 10. So I'm going to take 273 minus 10 times 26. 13 mod 26. So 17 goes to 13. How about 8? 21 times what? 8 minus 4 is 4. We're going to mod this by 26. So 21 times 4 is 84. Divided by 26 gives a quotient of 3. So my calculator went dead. Here it goes. 84 minus 3 times 26 gives me a quotient of 6. And finally 2. 21 times 2 minus 4 is negative 2. Now, I don't like the negative number, so I'm going to add 26. I'll get negative 2 plus 26 is 24. So I'll actually do here 21 times 24. I'll get 504 divided by 26 gives me a quotient of 19, so 504 minus 19 times 26 gives me a remainder of 10. Okay, so let's look at our message in letters. The message in letters, well, 2 is C. 4 is E. 11. What is 11? L. 4 is E. 1 is B. 17. Where's 17? R. 0 is A. 19 is T. 4 is E. 18 is S. 15 is, what's 15? P. 17 is R. 8 is I. 13 is N. 6 is G. 1 is B. 17 is R. 4 is E. 0 is A. And 10 is, what's 10? Okay. So here's your message. Celebrate spring break, it looks like. Celebrate spring break. All right, so those are some Affine ciphers. A little more difficult. When you're finding a decryption function, you have to find the inverse of A. Now, my question is something we didn't directly address. Why does A and 26 have to be relatively prime? Why do they have to have a GCD of 1? That means they have no primes in common. Well, the reason is because A has to have an inverse. In order to get a decryption function, you need an inverse of an A. In order for A to have an inverse, it has to be